Welcome to this project tutorial on building an Arduino Uno DCC accessory decoder. This one in this project is going to be controlling sound and lights, but the same decoder script I use for my turnouts or points, depending which country you're in. I've got it controlling a turntable, sector plates, lift bridge and a traverser in my fiddle yard on my layout. So this sketch that you'll be looking at is a very flexible sketch. Now I'm going to work through this as if I was building the project, because what I tend to see with a lot of people when they're trying to build up projects is they tend to rush at it and try it all in one go. So this project is broken down into two sections. There's the first section, which is the actual decoder script itself. The second section will then be how to get the effects built, and then at the end we'll stick them all together. So let's have a look at the Arduino IDE and we'll see how to get started on the decoder script. Now the decoder script I'm going to be using today is based on one in the nmra DCC library. Again, if you need to get that loaded onto your computer, let's see if mine will come up. Yep, here we go. Bring up the library manager, type in nmra. Shouldn't take long. There we are, the nmra DCC library. Now obviously I've got mine installed, so I'm not going to install it again. Once it's installed, you'll get some examples, and if you then go down to the nmra DCC library, you will find a script, nmra DCC Accessory Decoder _1. And if I bring up this script, it's one of those scripts that does a lot. It doesn't just do the normal accessory decoder, it does a number of other types of decoder, signal decoders, all sorts of bits and pieces. A very, very useful script, but for just controlling a turnout or triggering a sound or triggering a light, I didn't need all of this. So what I've done is I have stripped out everything that's unnecessary, and there'll be a link on the Digital Town website. It'll be a link below the video if you're watching this on YouTube, and it will take you to this script that I've created, which is called Blank Decoder nmra version 1. And this script is a very, very simple script. It includes the library. To set up the library, you have to do some initialization of the system. There is one function which we will come back to in a minute, and then in the setup, basically I've set up the serial output just so that I can see some messages coming out on the serial monitor. We then initiate the system using the interrupt pin, which is number 2. Now one of the things I advise people to do when they are creating scripts is in the header, in a sort of commented section, keep a note of the pins you're using, because when people are building projects, when they try to put two scripts together, very often they get a conflict because they're trying to use the same pin for two things. If you keep a list in your sketch as to which pins you're using, you will not have that problem. So we're starting on interrupt pin number 2. We then call an initialization script that basically starts the whole DCC library system running. Serial print to let us know it's happening, and then below here is a function called dcc.process. Now this is a function that is called endlessly, and all it is doing is listening for a call to interrupt pin 2. Now of course, to get that call to interrupt pin 2, we need some hardware. Now I'm not going to go into the hardware in great detail because I've put a link on the Digital Town website to this particular page, and it's a page minabay.com, and he's got a sketch a page here, DCC_monitor, and although the page is basically about how to build a packet analyzer or a packet listener, Quite a useful tool, by the way, if you ever want to have a go at one. What he goes through is how to connect your Arduino to a DCC system, because obviously your track is going to be running at sort of 16 to 18 volts in a sort of a weird form of AC, because that's how DCC signals go down the track. It's not a conventional analog DC, it's a sort of a square waveform pattern that goes through in a sort of an alternating current system. You can look up all the specs later for the details, but on this page, not only does he give the very nice circuit diagram for those who understand them, but for those who don't, he literally goes through step by step how to make a circuit that will connect to the track and to your Arduino. And basically this thing uses an optocoupler, and this means that on one side you've got the track high voltage, and then on the other side comes out sort of 5 volts or 3 volts, something around that area, that your Arduino will take without frying. Be warned, if you try to attach the track directly to your Arduino, you will release the blue smoke from your Arduino and blow it up completely. So you will need one of these circuits, and off of this circuit you will see that it connects to pin 2. Pin 2 is the interrupt pin. So again, the link will be on the website to the Minabay site. So basically this script connects to pin 2, and what I'm going to do now, I'm very fortunate, I've got lots of monitors here, so I'm going to I use DCC++ EX for my controllers. This would work if you connected to an NCE or a Digitrax controller. If you connected it up in the same way, you could just put out an accessory decoder command and you'll see the results. I'm using this system. I haven't got an actual controller attached, so I'm just going to put in this command by hand. So I'm going to send a command to accessory decoder number 25, and in my sketch that is the one I'm using. When I click send, you will see here that I see a number of results come back. In fact, I'll reopen that just so that it's totally clear. So we'll put that value in again, click send, and you'll notice that although I only sent the command once, the command has come through 4 times. That is not a fault. With DCC, when a command is sent out to the track, it's sent out a number of times, and that's because if you only sent the command out once and it was to a loco to stop the loco, if the loco happened to be on a dirty bit of track or something else was happening that caused a slight interference, the loco wouldn't pick up the signal, therefore it wouldn't stop. So the nmra sort of DCC handbook says it must send out the command a number of times, and that's why you'll see this command come out this many times. Now, what I've done, if we go to the one function that I've kept in, it's called notify DCC accessory turnout, and what it does is it gives me the address of the decoder and the direction of the decoder. Now in the original there was also the output power, but that's of no use to me, so I've commented it out, but I've left it in just in case you want to compare it with the original. And then what I do is I just add a simple switch statement. So I switch on the address, that's the decoder address. So in this case I've only got a decoder of value 25, so when a address is put in of 25, you'll see over here that 25 comma 1 was selected. That means decoder number 25 was sent a message, and the message was 1. So that 1 is the direction. So in this sketch, if it's 0, its serial prints out 0. If it's a 1, its serial prints 1, and above that its serial prints the rest of the command. So basically, because I sent that particular code. I'll put the opposite code in, put the 0 version in. Whoops, put it in the wrong one. Got to put it in the right window. There we are, put it in the right window this time, and there you see this time it's Accessory Decoder 25, direction 0, and my little switch statement has put the 0 in. So what you would do if you were creating a number of items on your decoder, some of my decoders have got 8 or 9 different addresses in use. So if I wanted to add in 26, it's as simple as that, and then where the serial print is, that is where we will put our code that controls whatever function, turnout, signal, whatever I want to do. This is where the code goes. So that is the overview of this very, very simple sketch. Of course, the next bit is creating the effects sketch, which we'll look at next. So before we get into any detail of the effects sketch, I'm just going to quickly show you a short video of 2 of the effects. The idea of this sketch, you can tell by the weird file name, Isle of Mud. IOM is the model railway that I build. I modeled the Isle of Mud. The script is on an Uno, and it is Shed version 1. Now the reason it is called that is my layout is a modular layout, so it's built on a number of separate boards, and this is the effects decoder for the engine shed board. A couple of other things just to notice: if you're downloading the sketch off the Digital Town website, it will come in one long file. You'll notice that I have my version in tabs. The reason is that all the commands for the serial UART are on one tab, and then all the sounds and effects are on another tab. When you start to build bigger projects, this makes life a lot easier, and also things like having all these commands on one tab means that when I want to build another decoder that uses all the sound functions that are in this script, I can just take the single file, stick it straight in the other project, and I'm away. It's going to work first time because it's been tested over and over. So if you have downloaded it as a single file and you want to break it up and you've never used tabs, there's a little button here. You click New Tab. I'll just put a test one in. We'll call it test.ino. And there we are. We now have a blank file. So that is how it's done, and when you want to get rid of it, just delete the tab. So let's have a quick look at these effects. The first one will be my arc welder, which is an arc welder sound that repeats itself a number of times, and as it does, you'll see there is a white LED that is flashing, and then after that you'll see an effect which is for the ash pit, where you'll hear the sound of a shovel going as the firebox is being emptied, and you'll see 4 red neopixels that start to sort of flicker away and slowly go out. Now these will be fitted inside some hot glue. The hot glue is then painted grey and a bit of black, and then you scratch it basically to make some little holes for the light to come through, and you get a really nice ash pit effect. So here's the video. Now, just to explain what was going on in that video, over here on this board, this is the nmra design of how you attach to the DCC track. Now you'll notice there's no track. Instead, let's bring this other picture in. This is my DCC++ test system. So this is using the Arduino based DCC++ EX system. It's basically using a motor shield. I've got it connected to my power supply. It comes through a unit that increases the voltage to the voltage that I want, because my power supply is set on 10 volts and I wanted it to be about 16 volts. This rail of my breadboard is my programming track. This rail of my breadboard is my running line. Down here you'll see that I've got a DCC decoder strapped in here. Very often you'll find that this is attached to a motor for when I'm building various DCC controllers that send the signals to these things. So we've then got the nmra system that is attached to the track. If you haven't obviously built a system like this, you might just want to put 2 wires to the track of your layout. The reason I do this is it just allows me to do everything on my workbench without having to go out into my cold garage to work on the layout itself. Now, going back to the unit, obviously that's my DCC system in the background. The power supply just happens to be built from an old computer ATX supply. There's a link on the Digital Town website if you want to build that project with the oscilloscope. So we've got the nmra system, which on that grey wire comes into pin 2. On the breadboard you can see the white LED. It's all a bit confusing, but coming off of this a couple of other pins is the serial UART MP3 player connected to the speaker. That's what's producing the sound. I've done a complete tutorial on how to use these boards. They're absolutely brilliant for model railways. Obviously the sound that you're hearing is not great because it's got this really cheap and tacky speaker on, but you can put good speakers on. So for the layout I've got some better speakers to plug in to get some better sound quality, and then I've got a string of neopixels coming off the board again. Now in the video you'll have noticed that only the first 4 neopixels were used. That's because I only need 4 neopixels in the ash pit. It's not that big an ash pit. The rest of the neopixels will be used when the code is expanded, because they will be used for the lights in the engine shed and various other parts of this particular board. So that is how my actual hardware setup is done for testing. You'll notice I've got a white piece of paper under it. This is because I do a lot of soldering on here. My soldering station's just to the right. Now and again I get little bits of wire that or solder on the board, and the last thing you want to do is start shorting out your Arduino on old bits of solder. So that's the reason it's on the white bit of paper. Okay, let's get to the sketch. So this sketch doesn't connect to the DCC system yet. This is just the sketch that I used to develop my code. Now, one thing I did before writing all my code, I played all of my sounds, and you'll see I've got all the sounds listed here, and you'll notice after them I've got the length of the sound, how long it took to play. You'll see why later in the code, but it was quite important that I had that. So let's get back to the sketch. Again, all the times for all the sounds are in there. Once again, I've put the pins. Although pin 2 isn't currently being used, I made sure that I listed it as used so that I didn't try to connect it. The serial UART player is having to use software serial and is on pins 3 and 4. Again, I've done a whole tutorial on that, so I'm not going to go into it in great detail. The neopixels are on pin 5. It's using the Adafruit neopixel library. I've got 16 neopixels on the board. couple of other variables that are important: the arc welder pin, weld state. These are just various variables that are used within the system. And then obviously I start everything up. I start up the MP3 player, select the card, I play a sound, and I go through a series of near-pixel colors. Basically I test everything when the script starts. That lets me know that everything is working. And then the only function that runs is this one, background sound. The reason there was a function here is that I was testing this function on its own. So when background sound starts, let's go into the sounds tab, it basically uses a millis timer. Now I'm not going to go into all the details of this sketch. If people want me to go further into how this is done, I'll do that later. But basically there is a switch statement on a variable called play this sound. A little bit later on, if the sound has ended, everything is on a millis timer. Now if you don't know about using millis, again I've done a tutorial on the Digital Town site about how to use millis. One thing, when you're working with a DCC decoder, you cannot use delay. When you use a delay for delaying something, that stops your entire Arduino dead. It's like turning the engine off, and it will not matter what sound, what buttons you press, what functions you press on your decoder, your unit won't hear it while there is a delay. That is why you cannot use delay, and it's why you need to learn how to use a millis timer. It'll be one of the best things you ever learn. But basically what this does is it, if no sound is playing, it picks a random number and picks a random sound and starts that background sound working. Each sound, so I've got one here, big machine, so I've created a function for each sound. The reason for doing that is some of them are just sound. So for instance, toolbox sound is the sound of someone messing around in the toolbox. It calls a function called play sound at volume, which is a serial WAV function that is in this part of the script. Again, that's all in the separate tutorial on how that works. It then says that the sound will end after 4 seconds. So basically this will keep running, and the script will not try and start any other sounds until 4 seconds are up. Now you'll also notice there's a thing called sound change, which I've got at 4 seconds. In this case it only plays the sound once, but on some of the other functions you'll find, for instance the arc welder, it plays the sound a number of times. I'm not going to go through all of this sketch, but basically what it does is it keeps flashing the arc welder sound and lights a number of times, synchronizing the two of them together. So there are bizarrely 2 millis timers running simultaneously. One is doing the sound, one is doing the arc flash, and you will find a similar system with the near pixels down here. The near pixels only shine for the first half of the sound. The reason is the second half of the sound, the loco will be filling with coal and the ash pit will have been emptied. So that's basically what's going on in there. Again, take a look through and see how it all works. But the important thing to understand is that everything is broken down into individual functions, and everything must run off millis. If you try to put that delay in, as I've said, you are going to have a world of pain with your whole decoder sketch. So once I've built this, and what I do with this is I basically have it on my test bench and I keep messing around with the breadboard until I've got all the sounds working on their own. I do not try and build it all into the decoder script in one go, and So this is built up gradually, bit by bit, adding sound by sound until I'm happy with the whole thing. So then it's a case of putting it all together, and we'll take a look at that next. So this is the final sketch, IOM Uno Shed version 2. I'm very strict on my versioning, so now if I wanted to make some more mods to this script, obviously I'll then save it as version 3, and I'd always advise you to do that sort of thing because it just helps you to go back to a good version if you wreck it, because there are times where you make some mods, you mess it up and you can't figure out what you've done, and it's quite nice to be able to go back to what was working rather than having ruined the whole thing. Let's face it, hard drive space is cheap. So going through the script, this time of course I've added the nmra DCC library in to basically what was the sound sketch. So the big difference is now is that when we go down to the setup, you have the DCC initialization before it goes through the sound and visual effects initialization. Now in the main loop, you'll see that now I've just got two functions. One is DCC process and the other one is background sound, which is that function that we had before. And so what I now do, and this is the joy of having written it all as separate functions, in the switch I've got, if it's case 25, so if decoder address 25 is sent, the value of sound on is 0. Now this is something that I added in to my sound system. So you'll see here that if sound on is smaller than 1, play sound has a value of 100. There's no sound on the board with a value of 100, and it just keeps delaying the sound. Basically it keeps delaying silence over and over again. So that's what happens when the sound's off. If I turn the sound on, then the background sounds will all start to play. Then what we have is, if I send the address 26, it sets the ash sound counter to 20, and it puts the sound end to the current time, the millis time, and this turns off the sound of coal or the ash pit effect running. So if I had a loco that was over the ash pit and all of a sudden I want it to move off, I can just turn the sound off and drive it away rather than having to wait for the sound to end. And again, if I want it to start, all I have to do is say play sound equals 17, which is that particular sound value. Sound start equals 0, sound end equals 0, and when I go into the sounds system, that will then cause this sound to be triggered in the switch statement. It's as simple as that. So I can now turn all the sound on or off, all the background sounds on or off, and I can turn the the ash pit sound on or off. Now one of the things that I've done in here is that if I start to if I put a loco over the ash pit and I want to start the sound of the ash pit and the coal loading going off, what it does is it immediately ends the background sounds. That's all written in the code in the sounds file, and then as soon as this sound has finished playing, the background sounds, if they're turned on, will then continue to play at random. Now when this is all finished, I'll hopefully upload some photos later of when this is all built into the layout. I'm still struggling to build a scratch built engine shed. It's turning out to be quite complicated due to the positioning. It's a sort of semi half relief building at a weird angle, quite a weird one to build. But once it's done, I'll try and get some photos uploaded. But I hope this has proved useful. The important sketch for you in these examples that we've looked at today, if you look at that nmra accessory decoder, and the other example on the site that I've built, the blank decoder. Again, if you want to build your own decoder, all you've got to do is to start adding different cases according to the address that you want the decoder to function on. This could be some code here to trigger a relay for a turnout, stepper motor, you name it. I've got one that triggers some signals, then it moves some gates, and then it lifts a lift bridge, and that's just a function that gets called in here. So I hope that's been useful to you. I'm sorry to have had to go through it quite quickly, and if people want any more details, just get in touch and I can always add some more tutorials. But if it's been useful to you, please click the like and subscribe button. One day I'll get to enough people that it'll actually mean something, but it's always an encouragement to keep doing more tutorials. So bye for now.